Hi everyone, it's Mr. Banish, and in this video we're going to take a look at gas behavior. To start with, let's review very quickly what a gas is. So we know from the previous section that a gas has no definite shape and no definite volume. So what does that mean to the molecules? It means that the molecules are going to spread further apart from one another, and they're going to continue to try to move further apart than what we've seen with solids and liquids. So ultimately these molecules are going to continue to expand until something stops them. And if we put this into a container, what we know is that it's going to continue to expand until they hit the outsides of the wall. And so what we're really concerned about in this section for gas behavior is how do the molecules change when we adjust the amount of pressure? So how do they act? Another thing we want to know is what happens to those molecules of gases when we change the temperature? And the other one that we want to know is if we change the volume, how are those molecules ultimately going to change as well? So let's take a look at each one of these individually. Let's start out by talking about pressure. Pressure is going to be the result of force distributed over an area. Okay, so it's the amount of force over the area. So let's take a basketball for a second, and let's put some air into the basketball. What we're going to see happen is that as we put more air into the basketball, and it begins to fill up, eventually it's going to get harder and harder to pump more of the air into the basketball. So what we're saying is that by increasing the force over that area, it's going to be increasing the pressure. And if we take air out of the basketball and we start pumping it back up again, it's going to be easier to pump until again we increase the force to a high level and the pressure is going to also increase. And we'll look a little bit more at that from a different perspective here. Let's take a soda can for a minute. Okay, so we'll take our soda can and let's put some carbon dioxide gas inside of there. What we know is going to happen is that the more gas molecules that you have, the more frequent the collisions are going to happen. And so by increasing the molecules, you are going to increase the frequent collisions that are going to occur. And that makes sense that the more molecules we have inside this can, the more times they're going to bang into one another. And since that is happening, we also say that it has a greater pressure. So one way to increase pressure is to ultimately put more molecules in there. It's going to create more collisions. And that's the same concept with this basketball, is that if we put more of the molecules, the air molecules, into the basketball, you're increasing the molecules, which means there's going to be more collisions that are occurring inside of here, and ultimately it's going to increase the pressure. And so that is one way of looking at pressure. It's ultimately more frequent collisions lead to greater pressure. So what are some of the factors that ultimately lead to gas pressure? So let's take a look at temperature. Okay, and we remember from a previous section that temperature is going to be the average motion of the particles in a substance. And so you might have experienced this if you've ever been riding along with your parents and they basically check the tire pressure before they go on a trip. And so let's draw a tire for a second. We'll label it so we know what it is. And so there's a tire, and if you check the air pressure before you leave, what you'll notice is that by the time you're done with the trip, so this is the beginning of the trip, to the end of the trip, what's going to happen is that the air pressure is going to increase. So the pressure is going to increase. So what's causing the increase of the air pressure? Well, what's happening is that those tires are going along on the road, and you're increasing how frequent they're making collisions with each other. And since that's happening, you're increasing the pressure. And so what we discovered is that if you increase temperature, so if you rise the temperature, you are going to make the particles move faster. And if you do that, they're going to collide more frequently. And if they are going to collide more frequently, we know that we're going to increase the pressure. Okay, so we increase, that's a U, sorry. I can't go any further writing over on the side there. And so you're going to increase the pressure. So let's think about that. You increase the temperature. So as your car is rolling down the road, it's making the particles move faster because you're increasing the temperature with the contact with the road. It's going to lead to more frequent collisions, so collide more frequently for the particles, and it's ultimately going to lead to an increase in pressure. All right. So if you want to have the same effect, or the opposite effect I should say, decrease the temperature, which is going to lead to particles moving slower, which is going to mean less collisions, which means that it's going to have a lower pressure. So pressure is affected by temperature by how often or how frequent the particles are going to move. And of course, this is making sure that we're talking about having the same volume, which is the amount of something per the amount of space, and having the same amount of particles that are inside each of these objects. So that's how temperature works. Let's take a look at volume. Okay, so let's take a look at volume. And volume is going to change based on this idea. And let's go back and think for a second. Let's imagine that we have some type of empty water bottle we'll use. And so let's try to draw that. It's a Banish drawing. And so if this is our empty water bottle, so we'll label it so we know what it is. And if you've ever tried to kind of squeeze your hand on it, what happens, especially if you have the cap on here, so if this is going to be the cap that's on the water bottle, what's going to happen is that you'll be able to squeeze it a little bit, but as you move further up, what's going to happen is that the volume is going to get reduced. And so soon you're going to see that there's a pressure and it gets harder and harder to squeeze that water bottle. And so what we know about that, so by squeezing a water bottle, just by doing that, is that if you decrease the volume, okay, so if the volume goes down, what's going to happen is that the pressure is going to increase. Okay, so we're going to increase the pressure. So just by squeezing the water bottle, as you work your way up towards the top of the water bottle and squeeze harder, it's going to increase the pressure, and this is going to be a relationship that we discovered. Now, if you want to have the opposite effect, you increase the volume, so make the bottle bigger, and by increasing that volume, you are going to ultimately decrease the pressure, and you're going to be able to squeeze it easier, and it's not going to be as difficult. And again, we're assuming that we're keeping the temperature and the number of particles that are inside of the water bottle the same. All right, so that's something that we use just for breathing ourselves. So when we contract our diaphragm muscle, it's going to ultimately allow for the chest cavity to open up. So it's going to increase, and I'm doing it right now, taking a deep breath in. It increases the volume and the pressure decreases. As I relax my diaphragm, the chest cavity closes and the volume decreases, and the pressure will increase then. And so that's volume. Let's take a look at particles for a second. So the number of particles, let's look at. All right, so number of particles. Before we said that if we have gases, They're going to continue to expand. But what happens when we have a whole bunch of the gases molecules together? And so what we discovered is that if you increase the number of molecules or particles, it's going to increase the pressure, which makes sense back to our basketball analogy. So if this is our basketball, we know that if you increase the number of gas molecules inside of here, it's going to increase the pressure. The ball is going to get hard and it's going to potentially overinflate. If you want to have the inverse effect, all you have to do is to take away the number of particles, and in return you are going to decrease the pressure. Right? And that makes sense too. So if we let air out of the ball, so will the pressure. Okay, so that's dealing with how we can ultimately change the behavior of the gas. Now there's two famous laws that we're going to quickly touch on, and the first one is going to be called Boyles Law. And Boyles Law ultimately states that if you increase the volume, you need to increase the temperature. Alright, so the inverse effect then would be decrease the volume and you will decrease the temperature. Alright, and this law is ultimately stating that the volume of a gas is directly proportional to its temperature. And this is basing on what we're going to talk about as being kelvins. And kelvins are a type of measurement used in the SI measurement. And so we're going to talk about this part of it in class. So for right now, just write it down, but we'll talk about it. But ultimately, what does that mean? It means kelvins equal degrees Celsius plus 273. Right? So we'll talk about that in class. And so what Charles discovered in his, Jacques Charles discovered, is that there's basically a straight line that's happening if we're talking about this being the volume and this being the temperature. As you increase the temperature, the volume is going to increase. As you increase the volume, so is the temperature. So it's a direct, sorry about the straight line there, but ultimately it's going to be the same. And so Boyles Law ultimately is saying that if you increase volume, you're going to increase temperature. All right. And the third law that we're going to look at is going to be Boyles Law. Okay, and so Boyles Law, done by Robert Boyle, ultimately states that the volume of a gas is inversely proportional to its pressure if temperature and number of particles are constant. So again, what this is saying now is that volume and pressure are going to be equal to one another. And so let's take a look at this experiment for a second. So let's take a basically any type of system where we have molecules that are inside of this container, and let's take something that we can ultimately push down on. Right? So imagine that we're going to be able to crush down on this. Let's just take a can, for example. And so let's take the molecules that are on the inside here, and we'll say that there are molecules of oxygen that are in there. And what we see is that as we begin to add pressure to the volume, because remember this is going to be the volume, which is the ultimately the amount of molecules that are in here. So as this object begins to push further down, so we'll say that now we have this much pressure going on, what we see is that the molecules get closer together. So what it does is it is going to increase. If we increase pressure, we're increasing the volume. Go down even further, so let's take it a little bit more. So here's our object that's pushing down. So let's draw it down. So what happens to those molecules? They get packed even tighter into the container. So ultimately what it's saying is that if you increase pressure, you are going to increase the volume. Okay? And so these two are proportional to one another is ultimately what it's saying. Alright? So we're going to look at these ideas in the lab with some things that we're going to do. So we'll talk about it more there. So take time, fill in the summary, and if you have any questions, make sure you add them so that way we can discuss it. Alright, talk to you later.